The Legendre theorem states for any positive integer n, there exist four integers, say w, x, y, z, and the n can be written by w squared plus x squared plus y squared plus z squared, right? So simply you can imagine like any integer can be, any positive integer can be written by sum of up to four squares, right? Square of four integers, including 0. That's the key part, right? So when you open your the four square sum Excel file, you are going to see like this one, right? Then just click that button that it asking, okay, what integer you want to check. And it shows up to 10 integers starting from whatever you give, right? So without touching anything, just click OK. Then it shows starting from 10 and up to 19. Okay? So as you can see here, all these numbers can be written by sum of actually up to four numbers, right? And each numbers are actually square of certain number. Okay? And actually the square means what? N square is square number, right? Okay? So as you can see over here. And the statement says there are four integers satisfying this, and some of this notation has only 3 or 2 numbers, right? Meaning is you include plus 0. So we accept repeated numbers like 1 plus 1, like that, right? So same thing happens here, 9 plus 9 plus 0 plus 0, right? Altogether. But of course, there are some other way to do that. Okay? So it's not saying there is a unique way to state it, right? It only just saying we can find four integers and sum of square of those integers will make that integer. Okay? I mean, whatever we choose. So if you want to do it again, just click that button and change the number. Then bigger number has more chance, right? More combination of those four numbers like that. Okay? And because it's Excel, not like Mathematica or Maple or something like that, so it really requires a lot of time if you ask really big calculation, right? So just be careful. I haven't checked that much big number yet, okay, but like 1,000, then still it's a kind of reasonable speed, right? Don't ask like 1 trillion, whatever, right? I never tried, pretty tried, but sometimes if it requires too much calculation, then it makes your computer frozen, right? So, but anyway, this one shows all these kind of examples like that, right? So I think it's good for checking the fact here. Okay, next one. In this theorem, we call that is the Fermat's polygonal number theorem. It says every positive integer can be written by sum of n most n n-gonal numbers. Okay, so let's start again, same way, 10. It also goes up to kind of 10 or 11 questions. And when you see those, these numbers are trigonal numbers, right? So the statement says n most n n-gonal numbers. So it can be done any n-gonal number, right? Not only square number, the triangle number or square number, right? But this Excel only shows the example using a triangular number. Okay, so triangular number means trigonal number, which means what? We have to up to 3 trigonal numbers only, right? No 4 or 5 of them, but it looks like it's working by there, right? So, and it says up to 3, so it can be 2 or it can be 1, it's also possible. So let me change the numbers to something else. How about 1, 2, 3? And all these numbers can be written by up to 3 triangular numbers. Okay, so have fun with those.